Good afternoon, everybody. My name is Gary Bolton from the National Nuclear Laboratory, and I'd like to welcome you to the first of five webinars to provide background information on the NDA annual PhD Bursary Call. Just a couple of housekeeping matters to begin with. This webinar is being recorded and will be made available via the NNL website. It is an open forum, and the presentational aids have been cleared for such a forum. Questions can be submitted via the BlueJeans software at the end of the presentation, which I can read out to the presenters. Please note that if the questions do deal with any sensitive material, it may not be possible to provide an answer today, but we will make a note of these questions and provide written answers, or at least attempt to provide written answers, which will be posted with the webinar recording on the NNL website. So I'd now like to pass over to Rick Short for a short introductory presentation on the bursary scheme.
Okay, thanks very much for that, Gary. Hopefully everybody can hear me. So I'm Rick Short, and I'm the research manager at the NDA, and I look after the University Interactions portfolio. So if we can move on to the next slide. Okay, so I'm just going to give you a brief introduction to why we hold the Bursary Call and why we hold a university portfolio at all at the NDA. And then we're going to move on to the technical presentation from the technical experts who are present. So it's going to be led by Nick Atherton from Sellafield and Richard Short from Doonray. I think we also have Angela Bartlett on the line as well from Magnox. And they're going to talk about the technical aspects relating to the land quality theme. And then we'll have the question and answer session at the end, where you can ask these guys any questions or ask for clarification. As Gary said, it is an open forum, so please be respectful of the presenters if they decline to answer any of the questions for sensitivity reasons. So as you can see, we've got a list there of the reasons why the NDA supports PhD research. The primary reason is always in the form of maintenance and development of the key technical skills that we need to deliver the NDA's mission. The NDA's mission is going to last a long time. It's going to be decades, possibly even a century, before we get to the point where we have truly cleaned up all of the UK civil nuclear sites. And so we're going to need several generations of technical experts to help us do that. And university research, PhD level research, is one of the ways that we sort of go about making sure we've got that skill set available over the time frame that we need. We're also looking to provide fundamental understanding of some of the technologies and processes that we use across the estate. A lot of the techniques that we employ in the nuclear industry are sort of adopted from other industries. You know, whilst they work, obviously, there are ways to improve them, there are ways to make them more efficient, and a lot of that requires this fundamental understanding that we don't necessarily have about how these technologies really work in our field. A lot of the technologies that we're working with are early stage, so this is technology readiness levels 1 to 3. Again, this sort of relates back to the fundamental understanding aspect, and a lot of these PhD projects are there to develop that early stage understanding so that we can progress these technologies through the higher TRL levels and eventually make them ready for deployment on site. And knowledge transfer is one aspect that we sort of really want to promote through the PhD scheme. And that's a sort of two-way knowledge transfer aspect. So that's taking the expertise from academia and applying it in the correct industrial settings, and making sure that that sort of new knowledge that's being generated in the academic environments, the cutting edge sort of data that's being collected and information that's being generated, is getting transferred to the right place in industry. That's why we have industrial supervisors for all of our PhD students. And simultaneously, we want to make sure that the knowledge is going the other direction as well, so that the areas that the industry are really in need of support in are being transferred back into academia, and the academics really understand what the industrial problem is and where the industrial drivers are. And again, the industry supervisors can help facilitate that knowledge transfer and help that exchange. Okay, so if we can go on to the next slide, please. So in this slide, I've just tried to sort of summarise the difference between the kind of research that the NDA is going to support through the bursary scheme, as opposed to that that's sort of funded by our site licence companies. So the NDA research portfolio, as I said, is really sort of about maintenance of key skills and capability. And as well as that, we sort of support R&D to encourage innovation and to help us make strategic decisions, so long-term decisions for the sort of future direction of how we're going to go about cleaning up the civil legacy. And the PhD Bursary Call that we're talking about today comes directly out of that NDA-sponsored research. One of the aspects that sort of applies to a lot of our research that we sponsor through the DRP is that it's got to be relevant to multiple NDA sites. So we're looking for, again, for ideas, for techniques, for fundamental understanding that's not just relevant to one site or one process, but is relevant to the estate as a whole. On the sort of opposite side of that diagram, we have the site licence company funded R&D. The site licence companies spend tens of millions of pounds a year funding R&D, but the R&D that they fund is generally needs-driven R&D. So it's often specific to a particular plant or process, or it's there to maintain a specific capability. So they're probably looking for, a technical expert in a specific subject to be the sort of next generation of person who operates that process on a site. And generally speaking, the reason they're doing the R&D, the ultimate reason is to improve the baseline for the site cleanup for that particular site. So again, if it's site specific or plant or process specific, that would be something that we'd be looking for the site license companies to fund as opposed to the NDA. So that's always worth bearing in mind when you're preparing proposals for the bursary scheme. And if we just move on to the last slide, please. So this last slide is just really sort of trying to give an impression of what our ultimate aim is in funding R&D. It's a slide I've used before, so some of you will have seen it before, but I think it really is a good illustration of why we need this kind of R&D. And ultimately, we're sort of, it's a definition of the NDA's mission. It's going to take over 100 years. It's going to cost somewhere between 95 billion, 218 billion pounds. Okay, this is a long time and a lot of money. So what we're trying to aim to do with the R&D is to reduce those numbers. If we can get the cleanup done quicker, then it will cost less money. If we can get it done for less money, then we can spend that money that we save on hospitals, schools, and other great things. This is all taxpayers' money that we're spending carrying out this mission. So the more we can save, the better. And ultimately, the R&D that we do at this level is going to feed into making this process more efficient. So we can make a really big difference to these numbers, and that's why we're supporting R&D via the NDA's direct research portfolio. Okay, so I'll pass you on now to the technical folk, and we can get into the meat of this land quality discussion. Thank you.
Okay. Hi, my name is Nick Atherton. I'm the current chair of the Land Quality Working Group, which sets the R&D themes for the land quality portion of the NDA bursary. I'll just introduce myself. I'm a technical manager at Sellafield Limited, and I currently work within the land quality team where we manage land and groundwater contamination on the site. I'm joined on the conference call by Richard Short from Doonray, who's going to introduce some of the topics later on. If we just move on to the slide that's got the working group activities on it. This slide here really just introduces you to this team of people across industry that I work with. We're a small group of people that form part of a wider working group that manage land and groundwater contamination across the nuclear estate. And we've got representatives from all of the NDA estate sites, plus sites outside of the NDA estate, such as AWE. A lot of the focus on the working group is to look at needs and opportunities that are across the NDA estate and across the nuclear industry, and try and draw out common goals and common pieces of work. And we also work closely with some of the other areas, such as the characterisation working group and the decommissioning working groups, to cross-fund R&D. And a lot of the work we do is let out through the direct research portfolio that Rick just introduced you to. If we move on to the next slide, I've just put a short selection of fairly recent projects that were done through the direct research portfolio, just to give you a flavour of the sort of breadth of work that we're currently working on. One of the main aims of the sort of working group is to draw in knowledge from external to the industry and external to sort of our everyday lives. So a lot of the topics on there are essentially writing best practice guides and bringing about new or fairly recently developed technologies and seeing if they could work in a nuclear environment. If we just move on to the next slide that's got the land quality topics on, I'll just give a brief introduction to these topics. So there's 4 topics in this year's Bursary Call for land quality, and it's a bit of a different focus to the previous years, where we've taken out some of the topics that have been there for quite a long time. We've had quite a lot of projects that have been ongoing, and we've essentially parked some of those original topics while we're waiting for the results of the ongoing work now. And a lot of the topics in this year's theme really focusing on a couple of areas that are fairly sort of common across the estate and fairly new in terms of the sort of focus that needs putting on them, particularly around the development of an environmental safety case for managing land and groundwater contamination and making it through to a site end state, and also looking at certain issues such as the pipelines that we have on our sites. So the rest of the presentation now goes into a bit more detail on these topics, just to sort of spark some ideas that might help you to develop the proposals. I'll hand you over to Richard Short to introduce the first one, which is on the contamination in concrete.
Thanks, Nick. As Nick was saying, my name's Richard Short and I'm based up here in Dounreay. I'm part of the environmental closure group, so we're essentially looking at the end of the site. The first point being the interim end state in about 20 years, and the next being the final end state in about 300. So that's our focus at the moment. So if we could have the next slide, please. So essentially, the site is made up of a number of buildings which often have concrete substructures, whether these house tanks or drains, or whether they're part of the foundations themselves. The idea behind the original bid was to leave as many of these in situ as possible to both reduce the amount of waste generated and to reduce the cost associated with pulling these out. The understanding that we have from the regulator is that these are potentially going to represent waste disposals. So there's obviously a need to understand how these are going to interact with the environment and make sure that the changes that we see in the environment are what we expect. So there's a variety of topics associated with that. Essentially, we don't fully understand the regulatory framework, so there's potential work in that area. We do have ongoing discussions with SEPA, but the intricacies of how our regulatory environment changes compared with in England and Wales is one area for discussion. Probably the main focus of the project is the actual mobilisation of contaminants from the concrete structures. So we have both radionuclides and chemicals of interest in there. So there may be radionuclides soaked to the concrete, there may be radionuclides within cracks and fissures. There's obviously the metals that went into the original concrete mix, there's the rebar, there's quite a lot of fairly complicated chemistry going on. And this is in an environment that changes from near surface oxidizing to subwater table to anoxic. So lots of different processes to go on to understand. If we could have the next slide, please. Hopefully we're on slide 6. I apologize, my computer's a little bit steam powered and creaky up here, so you have to bear with me.
We're on slide 6 now.
Brilliant. So linked into the leaving these structures behind is actually getting an accurate idea of what the structures are made of and characterizing these things. For some of the radionuclides, there's the potential for in situ characterization where we run a gamma survey across the top, which doesn't always work for some nuclides where we're dealing with pure alphas. Looking at optimizing the sample collection, we do concrete coring on some of these floor slabs, so we understand what's in the near surface and within a 2-inch circle, but outside of that area, we're really working on guesswork between sample locations. Linked into the characterization is understanding and identifying robust fingerprints and understanding how those fingerprints might change over time and across the different environments, whether we're dealing with near surface or subwater table. Another thing that we're interested in, which will come slightly into the case study, is the importance between the bulk activity in the concrete substructure itself and what might be on the surface where we've got very thin layers of radiological contamination along fracture planes or along pore surfaces, for instance. Moving on to the next area, we're looking at the backfill and pretreatment. Some of these concrete structures are essentially holding tanks, so they're big ponds in the ground. And decision needs to be made whether we leave that as a pond structure, whether we breach the floor and the walls to allow groundwater to leak out of there, but also leak into there. Whether there's a requirement to cap these structures or leave them open, and choosing the best sort of backfill, whether rubble backfill is optimal or whether it needs to be something solid to prevent more mobilization of contamination. Then the final subject area is the modeling and assessment, is underpinning these environmental safety cases that we're going to have to make for the end state of the site, optimizing the waste management plans and making sure that they're fit for purpose, and helping us with decision-making tools, making sure that when we're choosing what to do with the substructure, it's the right thing and it's underpinned by good science. And also understanding whether we need to put in place environmental controls, whether that, again, is back to the caps, whether it's interception walls, things to stop groundwater flow or redirect groundwater flow. If we could have the next slide, please. So slide 7 is a bit of a case study for one of the buildings we have on site. You can see the top right, we've got some areas of surface contamination marked. This was an alpha facility dealing with plutonium, so there's no gamma signature to use gamma probes. The left-hand side of the picture is the investigation tool we used, so concrete coring as an example core there. And you can see the way it breaks up. We've got some subsurface structure. We've got the granular backfill beneath the slab. And all of these potential targets where contamination might be present and might be mobilizing in different ways. And then down in the bottom right, we've got an example of one of the pond structures that's sitting below ground for tanks. You can just about see in the top right of the picture, the edge of the darker brown line represents the surface going down into rockhead. So we're talking several meters deep by several meters wide. This is a significant volume of material that we're dealing with. And so I'll hand back over to Nick for the next subject.
Thanks, Richard. So we should be on slide 8 now. So this topic is really a completely different sort of area. It's looking at how we communicate the environmental safety case for a nuclear site, specifically to do with how we develop and present the safety case for meeting the site end state. It also looks a little bit there about how we create a safety case and a permit around creating a disposal on a site. So this might be near surface disposal for radioactive waste. Through the development of an environmental safety case with a lot of detailed technical work goes into it, and a lot of quite difficult assessments and models get developed to inform the safety case and the planning to meet the end state. And it's quite difficult to get this sort of level of detail and the amount of uncertainty that sits behind the assessments into a format that you can, or that we can really talk to a range of stakeholders and really try and inform them what we're doing and why we're making certain decisions. So a lot of this theme's really about how we effectively communicate the environmental safety case for nuclear sites, either for cleanup or for disposal of waste on the sites. A good information source, I think, to look at to give you a sort of feel for sort of the amount of information that goes into an environmental safety case and the underpinning behind it, is to look at the low-level waste repository safety case, which a lot of the documentation for is online and available to the general public to view. Some of the potential areas that might be of interest is to look how we present the outcomes of environmental risk assessments. There's quite a complex sort of set of modelling scenarios that goes into them, looking at sort of how landscape changes over time and how climate changes over time and how it could affect the safety of a site going forward. Also, how contamination behaves in the soil and the groundwater over time, and how these climate and geological changes affect that behaviour and potentially change the risk profile going forward. If we just move on to the next slide. A completely different topic area again then is looking at the latest generation of sampling and analytical equipment. We've over the years, certainly on my site, we've tended to develop methods to really support operations of the site in terms of how we characterise waste streams and effluent streams, and certainly from my site how we support reprocessing operations. As we move forward, though, the sort of needs for sampling and characterization and analysis of samples changes. This is the case for land and groundwater contamination and building structures and things like that we deal with in the land quality area. I can't express enough, I suppose, how much effort really does go into characterization at the moment and the analysis of these samples. But we on our site, we certainly see that just growing almost exponentially as we move further into the decommissioning and remediation of the site. We need a lot of good quality data to support our decision making, and we need sort of robust methods to make those decisions. Whilst in the nuclear industry we've been fairly static, I suppose, with the sort of methods we use, there's a lot of development gone out around the world onto new types of equipment for sampling, new methodologies for analysing samples, and even new analytical instruments that may be applicable. And we've had some success in the last couple of years, including through the Bursary scheme of projects that have develop specific methods to analyze matrices that we're going to generate through land quality management and site remediation, and also new or taking newer analytical instruments and validating new methods on them for the analysis. Some of the topics that I think will be quite interesting is how we can take sampling equipment and methodologies that haven't been tried and tested on nuclear sites before, and showing how they could be applicable to a range of different characterization challenges, potentially looking at benchmarking new sampling equipment and methods to existing methods that we use more traditionally, to show that they are just as effective or they have benefits in terms of saving time and money. There's also taking the next generation or the current generation of analytical equipment and validating the methods for characterizing radioactive contaminants. Not something that's traditionally done unless we start asking for it specifically. And then I think one of the big drivers is to look at methods that allow us to characterize land and structures in situ and get quite quick data turnaround to allow us to make sort of decisions in quicker time. This will generally speed up the decommissioning remediation process. I think that's it from me now. I think if I hand over to Richard, I think maybe Angela to just introduce the last topic.
Thanks, Nick. So now we're going to move on to the last topic. We could move on to slide 10, please. So this is looking at investigation of discharge pipelines on nuclear sites. This one has some sort of overlap with one of our other sites. And Angela, if you want to chip in, feel free, just interrupt me wherever. So essentially, we're looking at discharge pipelines of various types, various diameters, things that are often well below ground level, sometimes even offshore. In the past, these have been investigated with ROVs. Some gamma surveys have been undertaken, but there is a potential that we're underutilizing some of the other data that could be collected. So looking at pH, EH, how the environmental conditions influence either the fingerprint or the contaminants that we're seeing. So a bit more detail on the topics. The first one is looking at how these radionuclides enter and exit these pipelines, whether it's within the pipeline structure itself, whether they're concrete or cast iron, but also whether they're in the corrosion products. So essentially, radionuclides, we're looking at anything that could have been generated on site and disposed of, so looking at a full range of fission products and actinides. And as I was saying, there's concrete, there's steel, there's cast iron pipes, so a fairly wide range of materials being used. In the past, we've done some fairly innovative ROVs. We've put ROVs down pipelines with cameras, we've done gamma surveys. By chance, we've managed to get some physical sample recovery, and that was purely stroke of luck that some material got stuck in the tracks of an ROV. But something along the idea of actually collecting physical samples from down pipelines would be potentially a real benefit. Move on to the next slide, please. Linked into the gamma surveys is the use of fingerprints, and essentially we're dealing with a wide range of uncertainties. Coming on to the case study a little bit on the next slide is one of the pipelines we've dealt with on site. And we've managed to get physical samples from near the surface where we're dealing with oxidizing conditions, quite close to the point of discharge, so potentially very turbulent flow. And then we're basing information from this area and trying to correlate that with what's happening down potentially an 800 meter, 600 meter pipeline. And it's really understanding how this fingerprint might change as we go down the pipeline, where we're transitioning to subwater table, potentially sub-sea water table where we've got a seawater freshwater interface, dealing with inside a cast iron pipe where oxidizing levels are going to be really low, where the cast iron's taking all the oxygen out of the water. Linked into this is really what analogs are there out there, whether there's any near-surface pipelines that are accessible that we could use as a model to take forward information, maybe some sort of a data survey and an application model of how this information can be applied into site analogs. But linked to that is how these analogs can be verified, because it's fine having a model, but you've got to demonstrate confidence in that model. If we could go on to the next slide, please, slide 12. This is one of the pipelines that we're dealing with on site at the moment. There's the 4 main discharge pipelines for the site, 3 of which have been capped. You can see in the top right picture, we've got cast iron pipes with about, I think it's a 9-inch internal diameter. So relatively small scale. We've got relatively good access to 3 of these, and you can see in the top left, that's pipe A, kind of continued along and into a different building, so you can see the access is a little bit more difficult. Down in the bottom, you can see the ROV that we're currently deploying on site. This is a gamma survey. As I was saying, we've got samples from close into these flanges on the pipelines, and it's really trying to understand how that fingerprint changes. We're finding that the activity is dominantly in the corrosion products, in the mix of sort of hydroxides and oxides. And we're finding from our fingerprint that the risk is very strongly dominated by the plutonium isotopes. The isotopes that we can't pick up using the gamma survey, but we're going to have to infer the presence of. I think that's about it from our point of view. I don't know, Angela, if you've got anything to add.
Yeah, I can make a few points just to add to the scope of what we're looking at, if that's helpful. Can you hear me?
Yep, go ahead.
Well, excellent. Yeah, the pipelines work. We've been working here at Harwell for about 10 years now. My name's Angela Bartlett. I've been looking at this for various different types of pipes along the site. And where our site has been quite straightforward in that it's all on the site, it's also been very complicated because we have like tens of kilometers worth of pipelines on the site. And we've certainly used various techniques to characterize them, but some of the other sites have much greater difficulty, and we will with our off-site pipelines, because there's many factors which make this very complicated. One of the things which we wanted to add to is one of the other site pipelines is, say, 1.5 kilometers long, and the distance between the access chambers is between 200 and 900 meters, and sometimes up to 1.5 kilometers. So deploying this equipment down there is obviously quite risky. You can't just get it back really easily for a variety of reasons. These pipelines often go across many landholders. There might be access restrictions to be able to go and rescue your probe. You've also got a problem with communicating with the probe. You've got problems with power. How do you deploy power along that long? Would you want to trust on a battery operated system? So as well as looking at the science of the detection, as Rick was discussing, we're also really interested in the actual deployment of it. And I think one of the things which is really important about this project, if someone was wanting to do a project on this, would be to go and talk to different sites and find out the constraints which we need to operate underneath, because there's a lot of physical limitations that these probes need to meet. One of the projects which was, I think it was, should have been on the list previously, was that there's been 2 DRP projects under the framework contract for the pipeline decommissioning. One of them is a good practice guide, and the other one was a technology review. And the technology review looked at various technologies available for characterizing these pipelines, but it mostly focused on those which were available in the gas industry, which was good from a technology point of view, except for the fact that they were used to dealing with much larger pipelines. Some of our pipes are down to, on the Harwell site, are down to 75 millimeters, which obviously limits the type of equipment that you can get down them. The other things that we need to think about, that if you're characterizing pipelines on site, you might be going under really active facilities, so that affects your signals and all sorts, as well as not being able to recover them. The other things you have to remember about is some of the other sites have got problems in that the equipment needs to survive down to quite a lot of pressure because it's under the sea. So that also means you've got to deploy certain types of equipment. I think that's all I'd like to say for now on the physical side of the equipment. So obviously there's some robotics issues in there, some communication issues with the probe and deployment. The other thing I wanted to mention was to do with the chemistry along the pipelines, and Rick talked about the analogs which we were interested in, and that is such that is there something you can measure that's not a radionuclide, which can it might indicate the presence of another radionuclide due to the similar chemical due to its chemical properties. So we're really interested in finding something that maybe you could even end up using a simpler type of equipment to deploy down a pipe rather than a full detector in order to look at the environment within the pipe. And hopefully that would really help out in our characterization activities. What else have I gotten down here? The other thing to mention is one of the things we've been looking at is influence of the materials of the pipeline and on the backgrounds, and that obviously strongly affects what you can pick up in the pipeline if you're looking with a gamma probe. So there's lots of different technical areas in looking at pipelines, but the main reason for a request for research is to take where we are now in the industry and be able to move on with that in a cost-effective and technically robust way. So I think that's all I wanted to say for now. If anyone's got any other questions, are we ready for questions yet?
Yes. Yeah, I think that's the end of the presentation. So we can have questions from anyone via the Blue Jeans software. And we can also ask questions over the conference call. There's a few NNL colleagues have dialed in. Yeah. Okay, we haven't had any questions in, so I think we'll draw things to a close. If you have any questions afterwards, you should all have contact details for Lindsay Rom here at NNL. Please forward questions to Lindsay, and we'll get responses out to you. So thank you very much for joining us today. Thank you to our speakers, and I think we'll leave things there. Thank you very much.